All right, we were looking at this problem last time where we found out that 648 joules of energy were lost or removed from the system due to friction and air resistance. So what we did not do was to look at the energy bar chart. So we'll do that now. You can see the energy bar chart from part A, where there was no work done by non-conservative forces, but now we're going to fill it in for the case where we did have the non-conservative forces. So the starting conditions are the same. We're still going from A to C. A is our initial, and point C is our final. So point A is still exactly the same. There's no kinetic energy. It starts from rest, and you didn't have to do 5 bars worth of gravitational potential energy up here. But if you did do 5 bars up here, then you should be doing 5 down here as well. No spring energy. Now we're going to skip over this for a moment. We know it's negative, so I'll start to draw it in there. But the kinetic energy, we know it's not quite as much as before. And actually we did this from A to B up there, so let's not even worry about that. If we had done it from A to C, we would have drawn this all the way up like this, and then it would have been 0 and 0. But that's not correct, because we know in this case we're going to end up with less kinetic energy. So let's erase this, and we'll come in. We know that the kinetic energy is less. It's not a lot less. It's 24 meters per second instead of 26 point something meters per second. So let's just go with 4 here. And that means if we want all of this to add up to 4, then this needs to be 1, say negative 1. So these numbers don't have units. They're just relative amounts so that we can get a visual representation of what's going on. Okay, so we had a certain amount of gravitational potential energy. Then we had less. We were removing some energy from the system so that at the end there's less energy left in the system. That other energy got removed, got dissipated as thermal energy.